our next speaker, who is Nikita Singh. She is a quality assurance professional with 3 years of experience, and she has worked across retail domains, and she's going to deliver about manual and learning through automated testing methodologies. So over to you, Nikita. You're on mute, Nikita.
Parinita, did you share the slide? Welcome.
Yeah, hi. Am I audible?
Yes, you are.
Does my screen is visible?
No, not yet.
Now?
Yes, it is visible now.
Okay. All right, everyone. Hi, everyone. I hope you all, after the break, we are all charged up and we have high energy. I hope so.
Yes.
Yeah, I'm not getting any response. Anyway, so as the team have already introduced, my name is Nikita and I have 1 year of internship, including 3 years of total experience. So I would like to share my background a bit. So I belong to a defense family and basically I belong to Uttar Pradesh, Banaras. But due to my father posting here in Vadodara and our higher education, we are settled here in Vadodara from past 12 years. I have completed my master's and I also love writing and reading novels. So I have published recently my first novel, which is available on Amazon. So if anyone want, they can go ahead and check. Okay, let's dive into the topic. So firstly, I just want anyone can guess and do let me know why I have used cats and fishes here. I guarantee this is not something usual session that you guys are attending. I am something bringing new to the table. So can anyone guess and do let me know why the cats and fishes are here? From the audience. Anyway, it's okay. I'm keeping it as a suspense and let's wait for the conclusion. So moving ahead, I'm going to break it down this session, how I'm going to conduct it. So firstly, I will let you guys know. Okay, let me share a slide first, slideshow. Anyway. Okay, so firstly, how I'm going to conduct the session is let's talk about deep learning. I hope most of the people are aware about deep learning already. So we'll firstly talk about deep learning, then the application that has been commonly used in deep learning, then the challenges of deep learning software testing that we are facing, then the traditional methods of testing a deep learning software, then how cats are different from the fishes and why the term cats are not fishes are being used here, and then in distribution versus out of distribution, then we will opt for a QA round. Okay, so before that, as I'm using cats and fishes, it is very, very important to let's talk about and appreciate the fur companion that we have in our life. So I hope many of us are animal lover. I am, and I have pet. And because of her, okay, so let me first talk about her. So her name is Lisa, and it's been 11 years of her having us in our life. So Lisa, because of her, my life has definitely changed. I am being more empathetic and compassion about others. I have learned a lot of things. So I hope you guys also have learned a lot from your companions and do love animals as I do. Let's move ahead with deep learning. So can anyone tell me what do I mean by deep learning, or whether they are about deep learning or not? And I think this is what exactly I mean by deep learning, right?
Nikita, sorry to interrupt. Do you want to put it on the presentation mode?
Yes, I guess. Okay, 1 second. I got it. It's gonna be, yeah. Is it visible now?
Yes.
Perfect. Yeah, okay. So can anyone tell me what do I mean exactly by deep learning? I guess this is what exactly I mean by deep learning, diving into under the water and opening the book and reading, right, guys? I think it's for laughing and it's just a meme, so we can laugh. I'm not even getting any reaction. Anyway, let's just talk about deep learning. So deep learning is basically a subset of machine learning that use multi-layer neural network, basically, which is called deep neural networks. So deep neural networks, how it's work, basically to its use complex decision making power of a human brain, and some of the AI application nowadays using deep learning. So after that, let's understand the difference between what is machine learning and deep learning, and why deep learning is booming and why machine learning is not. So machine learning is basically the structure for underlying neural networks. Let's take an example. Suppose self-driving cars. So companies like Tesla utilizing deep learning to enable autonomous driving features. The car are equipped with sensors and camera that feed data into deep neural networks, which process information about the environment, recognize objects, and make real-time driving decisions. The main difference between deep learning and machine learning is the structure of underlying neural networks. Traditional machine learning basically use simple neural networks and one or more computational layer, as deep learning models use three or more layers and typically hundreds and thousands of layers to train the model. So basically, what do I mean by this is deep learning is more complex and it provides you more accurate and efficient quality. So suppose if I want to you want to relate on and I want to give you a layman example, so you can say that machine learning is our, as we have lot of male audience, so machine learning is basically your Shubham Gill, and deep learning is your Virat Kohli. The reason as the Virat career is in cricket is booming, so that our deep learning is also booming. So let's understand the difference between machine learning and deep learning. I have bifurcated the both in four categories. First is basic concepts, neural network, learning capabilities, and visual analogs. So basic concepts. So first, let's understand machine learning is, let's think like thinking of it as a teaching a computer to recognize pattern in data using simpler models. And for deep learning, basically teaching your computer to recognize pattern using a more complex and deeper layer approach. And for neural networks, machine learning is basically using simpler neural networks with just one or two layers. Imagine you have two-story building. It's very easy to manage, but it's not very deep in neural network. But for deep learning, you basically use neural networks for more three or more layers, often thousands and hundred of layers, and complexity is basically like high tower, or you can say is skyscraper, allow the model to learn more complex features. Let's move ahead on the third category, which is learning capabilities. So machine learning is good for simple tasks, which basically, where you can easily understand patterns and identify, and where for deep learning can handle much more complex tasks like understanding image, speech, natural languages, because it has more layers to process the information. Let's move to the fourth category, which is basically visual analog. For machine learning, it is, suppose you have to understand is like, think of it as a single layer cake. You can add same flavor but limited in complexity. For deep learning, picture it as a multi-layer cake with lot of flavor. Each layer add more depth and richness. So the main difference is that machine learning use many more layer into models, which help it learn and recognize much more complex pattern in data. So basically, complex data. So deep learning is basically a powerful part of data science that help computers learn from a large amount of data, making them capable of performing tasks that usually required human intelligence. So that is what I mean by machine learning. So let's also deep dive and understand the two categories that machine learning provide. One is supervised learning and another is unsupervised learning. So supervised learning is basically, in supervised learning, you train a model on a labeled data set, means each input point has a corresponding output label. To initiate complex, consider a spam detection system for emails. Once trained, the model can classify new unable email as spam or not spam based on what it is learned. So unsupervised learning, basically it's don't use any label data. Instead, is look for pattern and structure within the input data. So unsupervised learning basically use cluster algorithm, process this raw data to identify pattern. It might find that certain customer frequently buying high value items while other trying to purchase lower price items. The model can group customers into different segments based on their purchasing behavior. For example, high spenders frequently bargain hunters. These insights can help the business, to plan the marketing strategy well, which basically help them in their business. So let's summarize this. So supervised learning basically need label data, unsupervised learning basically need patterns, and they both work on continuous improvement. So both type can adapt and improve over time as a new data. It's basically introduce this approach, allow business to gain insights and make decision based on raw data, and enable smart strategies and enhance operational efficiencies. So this is what I mean by this. Let's move ahead. And this is what exactly I have talked about machine learning and deep learning. And this is where I talk about supervised learning and unsupervised learning. So I'm not going to deep dive into it again. So let's move ahead on the application where deep learning software is commonly used. So these are the 4 applications which I'm not going to talk about it. So let's recommendation system, speech recognition system, healthcare, and gaming. So how recommendation system basically works. So nowadays, if you're aware about YouTube, Amazon, Spotify, Netflix, every platform is almost using deep learning to analyze user behavior and performance, and based on that, they make decisions. So deep learning algorithms predict what a user might liking and whether it likes. So on the basis of that, they will give you recommendation. And in healthcare, deep learning really helping and improving things. Suppose in the form of medical image detection. So suppose MRI, CT scan, X-ray. Deep learning models like and they are extremely used in radiology to autonomically basically detect abnormalities in your medical conditions and images, so that you can easily identify monograms to detect breast cancer at an early stage, and also lung infections or lung cancers, which is basically very helpful and great. So let's move ahead and talk about the challenges that we are facing with deep learning software. First challenge is the complexity of the model. So let's first talk about testing. Deep learning software is basically very challenging compared to traditional software testing. Deep learning software models are complex, data driven, and often behave in unpredictable way, which can make them difficult to test, validate, and debug. Due to that, it is complex. So first okay, yeah. So first one I can say is data dependency. For the challenge that we are facing with data dependency is that deep learning models are highly dependent on data they are performing, and can vary significantly depending on the quality, quantity, and variety of the data they are trained on. Suppose imagine you are testing a AI model that recognize the face in images, or if the trained data only include images of people with lighter skin tone. So the test data include people in darker skin tone, the model might not perform as well as you are expecting it to be. The model might fail to recognize the face because it hasn't seen enough driven data at the time of training. Moving ahead, with the lack of transparency is the second challenge that we are facing. It's also called as black box in nature. So deep learning models, especially deep learning networks, are often divided as black box. The models, it means basically understanding exactly how they make decisions is very difficult. Suppose you are testing a self-driven car. in deep learning models. So that decided when to stop at a red light. The model make an incorrect decision and stopping where it's not a red light. So it is very difficult for you to figure it out whether the decision is made, why the decision have made wrong, and what have made the decision misinterpreted. And so understanding and making a decision, it's very it's wrong. So yeah, these are the challenges that we are facing. Okay, let's move ahead with the problem with traditional testing methods, especially for deep learning models. So the challenges that we are facing with deep learning models is unpredictability of output. Traditional testing methods are designed for software testing, software that produce determined output, meaning if you give the same input, the software will always produce the same output. So basically, data dependency. Traditional testing often use static data sets that may not fully represent the variability and complexity of the real world. This can lead to the model that perform well during testing but fail in particular application due to overfitting or lack of generalization. Complexity of the model, as I already talked about, this is the biggest drawback that we have, that due to the complexity of deep learning, it is very difficult for us to test the softwares. Okay, let's move ahead. Dynamic nature of training. Okay, so unlike static software, deep learning models can evolve during training, making traditional testing method inadequate. A continuous changing in model architecture or parameter required more flexible testing approach to keep it with the ongoing improvement. So what do I mean by this is basically, due to the pattern change in the deep learning, you need to keep testing your software to match the latest change and improvement, else it won't work as expected. Lack of standard metrics. So traditional software testing often relies on clean predefined metrics for success. In deep learning, evaluation model perform can be more more fragile with varying metrics depend on the application, complicating the testing process. Resource intervention. Deep learning models can require significant computational resource, especially for performance evaluation. Traditional testing method may not be equipped to handle the scale and resource demand of training and validating deep learning system, leading to inefficient and longer testing cycles. So due to the inefficient resources, it will increase your testing cycles and deep learning that as well, and inefficiency as well. Okay, how cats are different from fishes. So can anyone tell me the characteristics of cats and fishes? Okay, so let's move ahead. Okay, so let's move ahead and understand how cats are different from the fishes. So firstly, understand cats are mammals and fish are aquatic. Sensory perception, body structure, behavioral complexity, reproduction method is all different. They are not the same. Okay, move to the next slide.
Nikita, before you proceed, there's a question. Is NLP and neural networks the same?
No. Actually, I'm not able to move my slide. I don't know why.
Just stop sharing and reach. Yeah.
Okay, it's yeah. The characteristics highlight the fundamentals difference. The cats and fishes are emphasizing the importance of understanding. So basically, why I've used the term cats and fishes are here is now coming to the picture. Suppose if you have designed the deep learning software, and I'm relating the term different modules and as cats and fishes. So suppose I have designed the deep learning software and as a cat, suppose I have given the name as a cat, and if I'm trying to test the same model using a test set of fishes, it won't work. So this is what exactly I mean by cats and fishes are here. So at the time of developing a deep learning model, you have to be very, very, have to understand that it should be domain specifically behavior and developed the model and thoroughly tested with all the data sets. Then and then it will work. Okay, so let's move ahead. Okay, again, I'm not able to. Okay. Okay, why cats are not fishes? So suppose you can see the cats are here are in distribution and the fishes are here out of distribution. So in distribution, basically cozy home scene, aquatic scene. So model trained on cat may not perform well with fishes, as I have already previously told, it won't work for fishes. So yeah. So why the cats are not fishes? There are some more differences, like different environment. They both have grown up. So basically, cat need more space, and fish need small space. Distinguished biological features, unique behavioral pattern, different nutritional need, evolutionary adaptations. So these are the different behaviors of both. So it won't work for one particular model. So cats and fishes are basically fundamentally different creatures with distinct characteristics and requirement. As I have already told, deep learning models need to be rigorously tested. As I have already told that you need to test it thoroughly to, if you want that to work, you need to test this thoroughly and adapt the different data distribution to ensure the efficiency and reliability in real world application. Okay, so let's understand the term in distribution and out of distribution. What do I mean by in distribution and out of distribution? So suppose in distribution is my cat and out of distribution is my fish. So in distribution is basically, I can say it is a familiar territory for a model of a data that is being have been trained well, and at the time of deployment the model expect in distribution data only, because it's able to recognize the pattern and the characteristics and everything, so that it can work well. So the challenges will occur when when in distribution data come into the picture, because the model is being designed on in distribution data and you are trying to test it using out of distribution data. So the model will not able to identify the pattern, the characteristics and anything, and it won't give you the exact result. So that is the difference between both. So you can read out the model performance and example scenarios, testing and validation, bias and limitations that I have mentioned here. And these are the important feature that is needed to test out of distribution, and why it is important to test to enhance the system more efficiency. So yeah, and yeah, this is the game basically. So, all right, guys. So what you have to do here is I have basically list down the terms which fall under deep learning, and I have what you have to do basically you have to rearrange the word according to the correct word which fall under deep learning. So I'm giving you 2 to 3 minutes. Once you're done, please do let me know so that I'm able to move ahead. Or we are good to skip this. I'm okay with both.
Audience, if we can help her with some inputs.
Yes.
No, you don't have to do. I mean, you can, if you get to know, you can as well unmute and tell it aloud or type it.
Yes, yes. If anyone able to guess it, please unmute and do let me know. Yeah, now I'm able
Is it
to.
activation?
I've tried to manipulate the words here and there so that people cannot easily guess it as well. So yeah, but it's very easy.
So what are they? They are some techniques, something like that.
Yes, yes. There are some algorithm techniques. Some
I can see
One
the
is
second
data
one,
set,
and
I
Yeah,
guess.
fourth one is
data
the
set.
data set.
Second one is overfit. I see.
second one is no, it's not overfit. I
Oh,
think
okay.
data set is right. Somebody says activation, that is also right.
Regular
Propagate.
regularization.
Back propagation.
Regularization.
Yeah.
Yes, that is basically an algorithm that is used to design the neural networks. So yeah, that is and convolution is basically a mathematical terms as to design to work with neural networks. So yeah, these are the term, and people can note it down, and you can read about it as well in later on. So shall we move ahead?
Yeah.
Yeah.
So these are the answers. You can correct or you can check it out and share. I will share the PPT if anyone want to know that. So yeah, now for the question and answer round, if anyone have any question, please do let me know.
As of now, we don't have anything posted on the chat. Anybody, any questions on what we have discussed till now?
And how was the session? I want to know.
It was a great session, Nikita.
Thank you.
Very interesting.
Thank you. So shall we wrap up?
Yeah, anything else that you have to share, Nikita?
No,
We're
it's
done?
fine.
Okay.
There's
Thank
one
you.
question: how are NLP and neural network different? Posted in the chat.
Yeah, I think we answered that in the beginning.
That, yeah.
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 You want to explain that?
1 second. Neural network. I think they both are different. NLP is basically neural. I'm not much aware about it, but I think they both are different. So I need to read more about it.
Cool. Thank you for a great session. Rohit is asking, do you have any idea on AI SDK available for mobile app development?
No, I don't have any idea about that.
Cool. Thank you, Nikita. Thanks. It
Thank
was
you.
having you with us. And thank you for all the games and the cat and fish comparison that you did. Thank you so much.